Hello students, you are watching video series for class 10 physics, and in this video we will discuss the questions and numerical problems from chapter 1 lesson 2 wave properties. The question number 1, a sound wave has a frequency of 192 Hz and travels the length of a football field, and the length of the football field is 91.4 meter in 0.271 second. What is the speed of the wave? Question B, what is the wavelength of the wave? Question C, what is the period of the wave? So while we solve questions in physics, numerical problems in physics, the first step is we need to write what is given in the question. So a sound wave has a frequency of 192 Hz. Frequency is given, so we will write frequency that is equal to 192 Hz is the frequency of the wave and travels the length of a football field. So the distance traveled is given, distance traveled that is equal to 91.4 meter. The time taken to travel that distance is 0.271 second. So time taken t equal to 0.271 second. So these are the things, these are the data given in the question. First one, the frequency is given, then the distance traveled that is length of the football field is given, and the time taken given. Question A, what is the speed of the wave? So how to calculate speed? Speed we represent by the letter V. Speed of any object that is traveling, or speed of a wave that is traveling a distance in a given time. So distance and time is given, so we can use the equation to calculate speed, distance over time. So here distance is 91.4. So distance is 91.4 meter, all given in the SI unit. So we do not have to convert the unit to another unit. We do not have to do that. So 91.4 divided by the time is how much? 0.271. So the answer will be 91.4 divided by 0.271. The answer is 337 meter per second. So 337 meter per second is the speed. The next we need to calculate the wavelength of the wave. So we know, now we know the frequency, right? We know the frequency and we know the speed. So how to calculate the wavelength? We need to calculate wavelength lambda. What is the equation to calculate wavelength of a wave? Wave equation, right? There is a wave equation. What is wave equation? Wavelength is equal to speed divided by frequency. This equation is called wave equation, and this equation connect wavelength, speed and frequency. So speed we already calculated, that is 337 meter per second, over frequency that is 192. So the wavelength will be 337 over 192. So the wavelength is 1.76 meter. 1.76 meter is the wavelength of the wave. Did you note? You can pause the video and write down. The next, what do we have to calculate? Then we have to calculate what is the period of the wave, the time period. Time period we represent by the letter T. So how to calculate time period? What is the equation to calculate time period? There is a relationship between time period and frequency. Time period is equal to 1 over frequency. 1 divided by frequency. So frequency is given, right? 192. So 1 divided by 192, how much? Time period is 1 over frequency, so 1 divided by 192. So 0.005 second, 0.005 to 1 second, 0.005 to 1 second. So this is the value of the time period. And there is one more question, that is question D. There is one more question in that question number 1, that is question D. If the frequency were changed to 442 Hz, what would be the new wavelength and time period? Before the frequency was 192 Hz. Now the frequency we increased, frequency of the sound wave, frequency of the wave is changed. Yeah, it's a sound wave, right? Yes, frequency of the sound wave is changed to 442 Hz. So what would be the new wavelength and time period? So what will be the new time period? Time period we represent by the letter T. Time period is equal to 1 over frequency, 1 divided by frequency, right? So time period is 1 by frequency we have increased, right? New frequency, that is equal to 1 divided by 442 is, right, new frequency. So time period will be less than the time period before 1 divided by 442. So that equals 0.00226, 0.00226 second. Before the time period was 0.005 to 1 second. Now the time period is decreased. So what do you have to understand? Whenever the frequency increases, when the frequency of the wave increases, then the time period will decrease. Frequency and time period are inversely proportional, that you can see here. When the frequency increases, because frequency is in the denominator, right? So whenever the frequency of the wave increases, the value of the period will decrease. Then we have to calculate the new wavelength also. We have the equation to calculate wavelength, that you know. Wavelength is speed over frequency. Speed will not change. 300, what is the speed we have calculated? 337, right? 337 meter per second. So the speed is 337 divided by frequency, that is 442 Hz. Wavelength, that is equal to 337 divided by 442, 0.76 meter. 0.76 meter. So what do you understand from this question? When you increase the frequency of a wave, when you increase the frequency of a wave, the wavelength will decrease. Frequency and wavelength are inversely proportional. When you increase the frequency of the wave, the wavelength will decrease. When you increase the frequency of the wave, time period will decrease. Do you understand? When you increase the frequency of the wave, the wavelength and time period will decrease, but the speed will not change. Here we used the same value for the speed. The reason is, when you change the frequency, the speed of the wave will not change. Speed of the wave depends only on the medium. It does not depend on the frequency of the wave. Speed of a wave depends only on the medium. Through that the wave is traveling. When medium changes, the speed will change. If you change the frequency, if you change the wavelength, if you change the amplitude of the wave, then the speed of the wave will not change, because speed of a wave depends only on the medium. Second question, how are wavelength, frequency and speed of a wave related? How do they depend on the medium? So here we have the equation, the wave equation. It states speed of a wave, that is equal to frequency multiplied wavelength. This is the relationship between speed, frequency and wavelength. Speed of a wave, that is equal to frequency multiplied wavelength. how do they depend on the medium? So frequency of a wave does not depend on the medium. Frequency depends only on the source that is producing that wave. Frequency depends only on the source producing that wave. How many times the source is vibrating, that is the frequency. So frequency depends only on the source. Frequency of a wave depends only on the source producing the wave. Frequency of a wave depends only on the source producing the wave, and frequency does not depend on the medium through which the wave is traveling. Means if the medium changes, if a wave travels from one medium to another medium, the frequency of the wave will not change, because frequency does not depend on the medium. Frequency depends only on the source which is producing that wave. Then what about the speed? Speed depends on the medium. Speed depends on the medium. Speed of a wave changes when medium changes. So we can say, right, speed of a wave depends on the medium. Speed of a wave changes when medium changes, but speed does not depend on the frequency or on the amplitude of the wave. Speed depends only on the medium. For example, for sound wave, the speed of sound wave in air is 343 meter per second, and in liquid the speed of sound will be greater than that. In solid, the speed of sound will be greater than the speed of sound in liquid. For example, light wave, another example, light wave. The maximum speed of light wave is in vacuum, that is 3 times 10 to the power 8 meter per second. And when light travels through glass, travels through water, the speed of light will be less, because speed of a wave depends on the medium through which the wave is traveling. And when a light wave travels from air to glass or from water to glass, its frequency will not change, because frequency does not depend on the medium. Question number 3. How does increasing the wavelength of a wave by 50% affect the frequency of a wave on a rope? So for example, we have the equation for frequency. Frequency is equal to speed over wavelength. Frequency equal to speed over wavelength. So how does increasing the wavelength of a wave by 50% affect the frequency? So here we are changing the wavelength. When we change the wavelength, the speed of the wave will not change, because speed depends only on the medium. If medium is same, then speed will be same. So if you change the wavelength, what happens? The frequency will change. And how much will be the change in the frequency? So you are changing wavelength. You are increasing the wavelength by 50%. For example, if the wavelength is 1 meter, then if you increase this by 50% increment means, what is 50% of 1 meter? 0.5 meter, right? 50% of 1 is 0.5. 50% means half. 100% means full. What is the 100% of 1 meter? 1 meter. What is the 50% of 1 meter? Which means half of that. That is 0.5. So if I increase the wavelength by 50%, so the new wavelength will be equal to 1.5 meter, right? 1 meter was the original wavelength, 50% increased, means now the new wavelength is 1 plus 0.5, that is 1.5 meter is the new wavelength, and the speed will not change, right? Speed will not change. So I can write what will be the new frequency. I will just write f dash to represent new frequency. New frequency, that is equal to speed divided by new wavelength. Why speed same? I did not use new speed because speed will not change. If you change the wavelength, speed will not change. When speed changes when you change the medium. Here you are not changing the medium, you are changing only the wavelength. So the speed is same, that is why we used V. Then what is the new wavelength? So we can write the new frequency, that is equal to speed divided by new wavelength. Speed divided by how much is new wavelength? New wavelength is 1. That is, if the old wavelength is lambda, then new wavelength will be 1.5 lambda, right? 1.5 lambda. So 1.5 lambda, that is the new wavelength. What was the old wavelength? Old wavelength was lambda. New wavelength means 50% increased, so 1.5 lambda. This is equal to, so if I write like this, the new frequency, that is equal to 1 divided by 1.5, 1 divided by 1.5 into V by lambda. Correct? This 1.5 I wrote here. So what is the new frequency? New frequency is 1 divided by this 1.5, and what is remaining? V by lambda. That is 1 divided by 1.5 into, what is V by lambda? V by lambda is the initial frequency, the original frequency, the old frequency, f. So what is 1 divided by 1.5? 1 divided by 1.5, that is equal to 0.67. So what is the new frequency? The new frequency is 0.67 times the old frequency, which means the new frequency is 67% of old frequency. Okay, that is the value of new frequency. Means when you increase the wavelength of a wave, the frequency of the wave will decrease. What? When you increase the wavelength of the wave, then the frequency of the wave will decrease. Frequency and the wavelength of a wave are inversely proportional. If you increase the frequency, wavelength will decrease. If you increase the wavelength, frequency will decrease. Now you increased the wavelength by 50% and the frequency decreased. How much decreased? It decreased by 33%. 33% decreased. So what is the new frequency? New frequency is 67% of the old frequency. For example, the old frequency was 100 hertz, and you are increasing the wavelength by 50%, then what will be the new frequency? New frequency will be equal to 67% of 100, that is 67 hertz. Question number 4. What is the speed of a periodic wave that has a frequency 3.5 hertz, frequency equal to 3.5 hertz, and wavelength is equal to how much? 0.700 meter. You need to calculate the speed of the wave. What is the equation to calculate speed? Frequency and wavelength given. So speed is equal to frequency multiplied wavelength, that is 3.5 multiplied 0.7, which equals 3.5 multiplied 0.7 equals 2.45 meter per second. Meter per second is the unit of speed, meter is unit of wavelength, and hertz is the unit of frequency. Question number 5. 5 wavelengths are generated every 0.10 second in a tank of water. What's the speed of the wave if the wavelength is 1.2 centimeters? So the wavelength is given, wavelength of the wave is given, wavelength lambda, that is equal to 1.2 centimeter, but wavelength is given in centimeter. Centimeter is not the SI unit of length, so we need to convert this into meter. So it will be 1.2. How to convert centimeter to meter? By dividing by 100, right? 1.2 divided by 100, so it will be 0.012. 0.012 meter. Then what is the frequency? Frequency is given, frequency is also given. How is it given? It is given that 5 wavelengths are generated every 0.1 second. Every 0.1 second 5 wavelengths are generated, means 5 waves are generated in 0.1 second. What's frequency? Frequency is number of waves generated in 1 second. What is frequency? Number of waves generated in 1 second, that is called frequency. So if 5 wavelengths are generated in 0.1 second, how much waves will be generated in 1 second? 10 times, right? 0.1. so what is 1 second? 10 times of, if you multiply the 0.1 by 10, you will get 1, right? So 1 second means 10 times of 0.1 second. So if 5 waves are generated in 0.1 second, how many waves will be generated in 1 second? 5 multiplied 10, right? So 50 waves will be generated in 1 second, and 50 is the frequency of the wave. We have to calculate the speed, right? Speed. What is the equation to calculate speed? Speed we are representing by the letter V. Speed is equal to frequency multiplied wavelength. So frequency is how much? 50, and wavelength how much? 0.012. so 50 multiplied 0.012, 50 multiplied 0.012, which equals 0.6. so the speed of the wave is 0.6 meter per second. Question number 6. In a periodic longitudinal wave has a frequency of 20 hertz. So frequency given, right? So frequency of the wave is 20 hertz. Travels along a spring if the distance between the successive compression is 0.6. so distance between the successive compression, that is called the wavelength in a longitudinal wave. In a longitudinal wave, there will be a series of compressions and rarefaction, right? Compression means low pressure region. Compression is high pressure region. Rarefaction is low pressure region. And what is wavelength of a longitudinal wave? That is distance between one compression and the next compression. Distance from one compression to the next compression, or one rarefaction to the next rarefaction. So here in this question, the distance between successive compressions is 0.6 meter, means wavelength of this wave is 0.6 meter. So we need to calculate the speed of the wave. So how to calculate the speed? Speed is equal to frequency times wavelength. So frequency is 20 hertz. Frequency is 20 hertz. So 20 multiplied wavelength is 0.6. So the answer will be 12 meter per second. 12 meter per second is the speed of the wave. The next question is, how does the frequency of a wave change when you double the time period? When you increase the time period by 2 times, so we have the frequency that is equal to 1 over time period, right? Frequency is 1 over time period. Frequency is inversely proportional to time period, which means frequency will decrease when you increase the time period. So when you double the time period, when you change the time period, when you increase the time period by 2 times, so what happens to the frequency? Frequency will change, or frequency will decrease by 2 times, which means frequency will be half of the new frequency will be half of the all the frequency will decrease to half of the initial frequency. Next question, describe the change in wavelength of a wave when the period is reduced to 1/2. When the period of the wave is reduced to 1/2, what will be the change in the wavelength of the wave? So what is the equation of the wave in terms of the time period? So we have equation for the wavelength, right? Wavelength lambda, that is equal to speed divided by frequency. That is the equation for wavelength. So lambda, that is equal to speed divided by frequency, 1 by frequency. What is 1 by frequency? 1 by frequency is equal to time period. So what is wavelength? Wavelength is speed of the wave multiplied the time period. Wavelength lambda is equal to speed multiplied the time period. So when you decrease the time period to half, so what happens to the wavelength? Wavelength will decrease by half because the speed will not change, right? Speed depends only on the medium. If you change the period, if you change the time period of the wave, speed of the wave will not change. Why? Because speed depends only on the medium of the wave. So if you decrease the time period to half of the initial value, then what happens to the wavelength? Wavelength will also decrease by half of its initial value. So if you decrease the time period by t by 2, means if you change the time period to t by 2, means half of the time period, then wavelength become half of the initial wavelength. The next question, if the speed of a wave increases to 1.5 times original speed while the frequency remains constant, how does the wavelength change? Speed is increased, right? So we have this equation for wavelength lambda, that is equal to speed over frequency. So here speed is increased to 1.5 times the initial speed. So what happens to the wavelength? And frequency is not changing, frequency is constant, right? So what will be the new wavelength? What will be the new wavelength if you increase the speed by 1.5 times the initial speed? So wavelength will be, the new wavelength will be, you can see V by F. What is V by F? V by F is the original wavelength, the initial wavelength, the old wavelength. So that is 1.5 multiplied the old wavelength, right? 1.5 multiplied lambda. So when you increase the speed by 1.5 times, then the wavelength will also increase by 1.5 times, because wavelength means the distance traveled by one wave or distance traveled within its time period. So if it is moving faster, means if the wave is moving faster, it will travel more distance in its time period. So if you increase the speed of a wave, the wavelength will increase. If you increase the speed by 2 times, wavelength will increase by 2 times. If you increase the speed of the wave by 3 times, its wavelength will also increase by 3 times. If you increase the speed by 5 times, wavelength will also increase by 5 times, but frequency will not change. Why? Because frequency depends only on the source that producing that wave. In the next question, a boy is shouting from here. He is 465 meter away from a cliff. So what happens is the sound will go. So the boy is here. The boy is here and he is shouting. This is 465 meter away from a cliff. So what happens when he shout? His sound will go towards the cliff. It will hit the cliff and it will come back, right? When it comes back and when it reach his ear, he will hear the echo. He will hear the echo, and echo is heard 2.75 seconds later. He is shouting from here, and the sound is traveling to the cliff, then coming back. Then he can hear the echo of his sound. So what we need to calculate? We need to calculate the speed of the wave. Speed is equal to, we know that, distance divided by time, right? Speed of a wave is distance traveled divided by time. So here what is the distance traveled by the sound wave he produced? So the distance traveled is, first the sound is traveling from his mouth to the cliff, then it is returning to that boy. So the distance traveled is 2 times 465 meter. Why 2 times? Because the sound has to go to the cliff, 465 meter sound traveled, then it has to come back, it has to return, right? It is going back to that buoy, again traveling 465 meter. So the what is the distance traveled? 2 times 465 meter divided by the time taken. How much is the time taken? 2.75 second is the time taken to travel that distance. So it is 2 times 465 divided by 2.75, which equals 338.2 meter per second. That is the speed of sound. So we calculated speed of the sound, and what do we have to calculate next? We have to calculate frequency. What is given? Speed is given. So if speed is given, how to calculate frequency? Frequency is equal to speed divided by, wavelength is given, right? Yeah, wavelength is given. Speed we have already calculated, so 338.2 divided by wavelength, that is 0.75. so frequency will be how much? Frequency will be divided by 0.75. so frequency is 451 hertz. 451 hertz is the frequency of that sound. And what we need to calculate the time period. How to calculate the time period? Time period is the 1 over frequency. Inverse of frequency is the time period. So time period t is equal to 1 by frequency, 1 divided by 451 hertz, which equals 0.002. So the time period is 0.002 second. That is the value of the time period, 0.002 second. It's not 25, 0.002 second. That is the value of the time. The next question, I forgot the question number. A sound wave of wavelength 0.6 meter. So wavelength is given. We will write wavelength of the sound wave is 0.6 meter, and velocity of 330 meter. Velocity and speed is same, 330 meter per second, not meter, meter per second, and is produced for a time duration of 0.5 second, not time period. Okay, so the time duration is given, that is 0.5 second. First we need to calculate what is the frequency of the wave. We need to calculate the frequency. What is the equation for frequency? If wavelength and speed is given, so we can calculate frequency like this, right? Frequency is equal to speed over wavelength. So we will use that equation. Frequency is equal to speed over wavelength. How much is speed? Speed is 330 over wavelength. Wavelength how much? Wavelength is 0.6. 0.6. So this equals how much? 330 divided by 0.6, that equals 550 meter per second, right? 550 meter, sorry, not meter per second. What happened? 550 hertz. Hertz is the unit of frequency. Then next, how many complete waves are emitted in this time interval? So which time interval? The time interval is 0.5 seconds. 0.5 second. What is the frequency? Frequency is 550 hertz, which means 550 complete waves. 550 complete waves are produced in 1 second, but here the time interval is 0.5 second. So how much waves will be produced? So question B, in 0.5 second, how many complete waves will be produced? So number of waves, I will just write n for number of waves produced in 0.5 second. That will be 550 multiplied the given time interval. So here given time interval is 0.5. So how to calculate the number? The number of waves produced you can calculate like this: frequency multiplied the time interval given. So frequency 550, so this will be 225, right? 225 complete waves will be produced. So it is a number of waves. Number does not have unit, so 225. And what's the question C? After 0.5 second, how far will be the front of the wave from the source? This is the source producing the sound wave. After 0.5 second, this sound E. After 0.5 second, where will this sound reach? So how to calculate the distance traveled? The distance traveled, that is equal to speed multiplied time, right? Distance traveled is speed multiplied time. What is the speed of this sound wave? 330 multiplied the time taken is 0.5. So after 0.5 second, where will be this sound? 330 multiplied 0.5, which equals, it will be 165 meter away. 165 meter away. So the answer is 165. You may not be able to see the bottom of the board in the video, so I will write here the distance traveled will be 165 meter. So the sound I am producing now, where will it reach? After 0.5 second, it will reach 165 meter away. The next question, speed of sound in water is 1498 meter per second. See, 1498 meter per second speed is given, so we will write speed 1498 meter per second. Whenever you solve any problem in physics, write what is given in the question when you start reading the question. So here you can see 1498 meter per second. Speed of sound in air was how much? 343 meter per second, right? So speed of sound in water is much greater compared to speed of sound in the air. A sonar signal is sent straight down from a ship at a point just below the water surface, and 1.8 second later the reflected sound signal is detected. So reflected signal detected after a time of 1.80 second. So we need to calculate the distance to the bottom of that. If it is sea, so we need to calculate the depth, right? So distance to the bottom of the sea. So we need to calculate a distance. I will write here. So what happens? So this is the water surface, and here is the sea. See here. So this is the bottom of the sea, and here is a ship. So this is a ship. So how to draw here? Okay. Yeah, this is a ship. So this ship is sending a sonar signal, means a sound wave, straight down to the bottom of the sea, and this sound wave, this signal will go and hit the bottom, the seabed, right? Bottom of the sea, and it will be reflected. After 1.8 second later, the reflected sound reached here. The reflected sound detected by the ship, by the receiver in the ship. So we need to calculate this distance. We need to calculate the depth of the sea. So what we will do, we will multiply speed and distance. So we will get total distance traveled. So what's the meaning of total distance traveled? Total distance traveled means that the distance traveled by the sound first to reach the bottom, then here it is reflected, then it had to go back to the ship. So first we will calculate the total distance traveled. That will be actually 2 times the depth, right? 2 times the distance from the water surface to the bottom of the sea, to the seabed. So to get the depth, we will calculate the total distance traveled, and we will divide that distance by 2, means we will take half of that distance. So how to calculate the total distance traveled? The total distance traveled, that is, here we need to calculate the depth, right? Depth. Okay. Total distance traveled, that is speed into time. Speed is 1498 and time is 1.8. So 1498 multiplied 1.8 equals 2696.4, 2696.4 meter. And what is the depth? the distance to the bottom of the sea, divide by 2. So when I divide by 2, 1338, 48, 48.2 meter is the depth, the distance to the bottom of the sea. Next question, two friends are resting on offshore raft after a swim. They estimate that 3 meters separates a trough and adjacent crest of each surface wave. They count 12 crest bypass in 20 seconds. Calculate how fast are moving. So to calculate the speed, how fast means we need to calculate the speed. To calculate the speed, we need frequency and wavelength. So how much is the frequency? Frequency, they count 12 crests in 20 seconds, right? So in each wave there will be one crest and one trough. So if there are 12 crest means there are 12 waves. 12 crest means 12 waves. In what time? In 20 seconds. So frequency means number of waves completed in 1 second. So frequency we can calculate like this. Frequency is equal to 12 divided by, because 12 waves are produced in 20 seconds. So how many waves produced in 1 second? 12 by 20. 12 divided by 20. So 0.6 is the frequency. 0.6 hertz is the frequency. So how much is the wavelength? Is wavelength given in the question? So first we need to calculate the wavelength also. Wavelength. See here, what is the meaning of wavelength? Wavelength is distance from one crest to the next crest. Wavelength is distance from one crest to the adjacent crest, or one trough to the adjacent trough. So here it is given the distance from one trough, right? They estimate that distance from one trough to the crest, trough to crest, that is 3 meter, right? So the wave will be like this. So this is crest, this is another crest, this is the wavelength. But what they do, they are estimating the distance from one crest to the trough. So they are estimating distance from one crest to the next trough. So this is the distance they are estimating, and they got it is 3 meter. So we need distance up to here, right? So what is the wavelength? Wavelength is equal to 2 times, because they estimated distance from crest to trough. We need crest to next crest. So it will be 2 times their estimated distance. Distance means distance between one crest and one trough, that is 3 meter. So wavelength will be equal to 6 meter. We need to calculate the speed. So speed is equal to frequency multiplied wavelength. 0.6 multiplied 6, so it will be 3.6, right? 3.6 meter per second is the speed of the waves in that water surface. So in this question, a frequency of yellow light is 5.1 times 10 to the power 14 hertz. Find wavelength of the light if the speed of the light is 3 times 10 to the power 8 meter per second. So we know that wavelength lambda, that is equal to speed over frequency. Speed how much? Speed is 3 times 10 to the power 8 meter per second. And what is the frequency? The value of frequency is 5.1 times 10 to the power 14 hertz. 5.88 times 10 to the power minus 7 meter, 10 to the power minus 7 meter.